I'm John McQuay with 8541 Tactical, and we're here with our next installment of our Mega Arms MATEN build. Today we're going to talk about our operating assembly, how we chose the parts that we did, and how we can check to make sure that it's going to function with our barrel. Well, I'm going to tell you right off the bat that we chose to go this time with a DPMS bolt carrier group. One of the primary reasons is that's really all that was available to us right now, because everyone seems to be back ordered or out of stock on bolt carrier groups. My guess as to why this is right now in our current climate, the rifles are selling like hotcakes, and all the bolt carrier groups are more than likely going into rifles with very few left over to go out into commercial sales. Now with the Mega Arms MATEN upper and lower receiver, you're free to utilize whichever pattern you wish between DPMS or Armalite type parts. The Rock River Arms and some of the other parts out there are not compatible, so you want to steer clear of those. It's either DPMS, Knights Armament type parts, or the Armalite pattern parts. Now the Mega Arms MATEN lower receiver feeds from a Stoner SR25 DPMS pattern magazine. So that you're locked into, but you're free to choose either an Armalite or a DPMS type bolt carrier group, because either of those will feed from that magazine system. The outer dimensions on those two systems are very, very similar. They are almost duplicates of each other with very small changes between the two. We went with the DPMS this time because of availability, but also because I kind of wanted to compare and contrast the DPMS bolt carrier group and the Armalite bolt carrier group that I used in the last semi-automatic rifle build we did. I'll tell you right off the bat that the Armalite bolt carrier group is a little bit better finished product. They smoothed off some corners, they're a little bit finer on the tooling marks and the actual fit and finish of the product. I like the fact that I can take apart the Armalite bolt carrier group and field strip it without using any tools whatsoever. Those are really, really small points. Overall, I didn't see anything between the two bolt carrier groups that would really make me think that one was a bad choice over the other. The two that you will see the most are the DPMS bolt carrier group and the Armalite bolt carrier group, and they're pretty much neck and neck in price. JP Rifles does make their own bolt carrier group. They make an enhanced bolt and a lighter weight bolt carrier. They are just fine for use in the Mega Arms MATEN build. In fact, we considered that build, but we wanted to keep the bolt carrier group in a more reasonable price range. The JP part is several $100s more expensive than either the DPMS or Armalite bolt carrier group. However, we've gotten reports that it's extremely high quality, so should you decide to go that direction, that may be a good option for you. A little bit later on, we'll try to get a hold of one of those bolt carrier groups and report back to you on what kind of quality we have with those JP parts. Now, moving on past the bolt carrier group, we selected a JP custom operating spring for this rifle. Because we're using the Magpul PRS stock, we need to use a rifle length operating spring and rifle length buffer. The JP spring is a higher spring rate than what you'll find in a standard AR-10 or LR-308, and it is polished and smoothed out, and they're claimed to reduce some of the noise in the AR. ARs are notorious for sproing when the spring compresses and expands, and the JP spring is supposed to help minimize some of that. Next, we have our buffer. Now here we used a DPMS LR308 buffer simply because I went with the DPMS bolt carrier group and I wanted to see if dimensionally there was a difference between the two. There's a very, very small dimensional difference between the Armalite and the DPMS carriers. It's about a millimeter difference between the two. So my suggestion would be, if you decide to go with the DPMS bolt carrier group, use a DPMS buffer. If you decide to go with the Armalite bolt carrier group, use an Armalite buffer. However, the catch is there's no dimensional length difference in the actual bolt carrier group itself. It's not going to be a catastrophic difference if you decide to go with the Armalite and a DPMS bolt carrier group, or vice versa. It just was easier for us to order them all in the same spot. Now that's it for our operating assembly. The bolt carrier group, spring, and the buffer need to match, and these parts are specific to the .308 caliber ARs. You cannot interchange them with an AR-15. It shouldn't need to be said, but we're saying it anyway. While a AR-15 operating spring and buffer will fit in this Mega Arms MATEN that we're building, it will not work. You'll more than likely damage the rifle, and you may cause injury to yourself. If you have cause to disassemble both a .308 AR and an AR-15 in the same area at the same time, you may want to make sure that you have the .308 buffer marked as such. That way when it goes back together, you don't get the parts mixed up, because again, that could cause serious damage to you or the system itself. So that is our operating assembly. Now let's move on to our barrel. For this project, we chose a Rainier Arms Select barrel. I was very impressed by the value that these barrels offer. This is a stainless steel barrel. It is a 1 in 11 twist. This one is 16 inches, although they're available in a variety of different barrel lengths to suit your needs. It is a lighter weight profile than many of the other .308 options out there, and it utilizes a DPMS mid-length gas system. Ideally, you'll want to purchase your bolt and your barrel from the same place so that they can check the headspace for you and make sure that your bolt and barrel will function correctly and safely together. However, very often you'll either have one or have the other and need the other component, or you'll purchase them from two different locations. Then it becomes your responsibility to make sure the rifle is safe to fire. If you're having a custom barrel made, you'll want to send your bolt to the barrel manufacturer so that they can match up the barrel and chamber the barrel appropriately for your bolt. But if none of that's true, we'll go ahead and show you how to safely determine if your bolt will work with the barrel that you've ordered. Now, in order to check the headspace of your barrel, you're going to need two little special tools. They're called Headspace gauges, and the ones I have here are Forster Headspace gauges. These are for commercial .308 Winchester, and there is a difference between .308 Winchester and 7.62 NATO. The headspace differences, in a nutshell, is a .308 Winchester chamber is tighter than a 7.62 NATO chamber. And we're going to show you a little bit of that here in a minute. Headspace is important because rifles and ammunition, of course, must work together. There has to be a specification range between ammunition and rifles for them to reliably function across a wide array of manufacturers. So SAMI has come up with a range that a chamber can fit in and still be safe to fire, and a range that ammunition can fit in and still be safe to fire. We don't really have any control over commercial ammunition. What we can control is what the headspace is on the rifle that we're building. Now, when a rifle fires, there needs to be a little bit of slack between the chamber and the cartridge so that the cartridge can feed into the chamber, and when you're done firing, so that the cartridge can extract and eject from the chamber. The problem that you run into is when there's too much slack. Now the brass has to expand too quickly and too far and can rupture and release that pressure into your face and damage the rifle or damage you. So what we're checking when we're checking headspace is we're making sure that the chamber is tight enough to support the case, but not so tight that the cases will not chamber and eject reliably. The easiest way to check it is we need to detail strip our bolt. Detail stripping the bolt means you need to remove the extractor and the ejector from the bolt. There are tools that are made to do this. However, I prefer to make my own little tool because it's very quick and simple. All I have here is the head of a .308 Winchester case. We just cut the case body off and left about 1/4 to 1/2 inch of case sticking out. Go grab you a grip clamp like the one here, and while your ejector is still in the bolt, you're just simply going to put your little case head in there, and you're going to clamp it together in your grip clamp. You're going to get in there nice and tight so that the grip clamp pushes the head of the case in and compresses your ejector. You'll then drive out the roll pin with a small punch and set that aside. Now, these roll pins are really small and fine, so make sure you don't lose it. If you've got one of the Auto Parts magnetic trays, those are real nice to have around when you're working with small parts like this, because they'll stick in that tray and they won't go rolling off even if you knock the tray over. Once you've driven the pin out, I prefer to leave my punch in the pinhole, because once you've driven out the roll pin, the punch is what is actually retaining the spring pressure and retaining the plunger in there. Just wrap your hand around the end of the bolt, release the punch, and then release pressure on the bolt. And that spring pressure will push the case head out just a little bit, but it won't go shooting out if you release pressure slowly, because the ejector will only extend out about that far. So you can gently release the pressure, then pull out your plunger and dump out your ejector spring. And for a couple of bucks, it's a real easy setup. Now, if you don't feel comfortable doing this because you're afraid that the spring is going to eject the plunger and everything's going to go flying, get a clear trash bag and just cover your work area with the clear trash bag and do it underneath or inside of a clear trash bag. That way you can catch that pin if it goes flying. If you're a little bit smaller hands and you have a smaller clamp to work with, you may be able to do it inside of a Ziploc bag, but a large clear trash bag will probably work pretty well for you. Now, the reason we need to remove that ejector is because we don't want to put any pressure on the back of our Headspace gauge when we're using them to measure. The first thing we want to do is we want to check to make sure that our bolt will close on our go gauge. Our go gauge represents the maximum size of commercial loaded ammunition. You shouldn't find commercially loaded rounds out there for .308 Winchester that exceed the dimensions of a .308 go gauge. So we're just going to drop the go gauge into our chamber. We're going to take our bolt, insert our bolt on top of it, and you should be able to push your bolt down and rotate the bolt freely within the barrel extension. This means that the bolt has gone down and closed far enough that the lugs on the bolt clear the lugs in the barrel extension and you have room to rotate it. That tells me that this chamber passes the go gauge. It should be able to chamber most factory .308 Winchester rounds. Now, the other part of this is we need to make sure that the chamber is not too large, because if it was really large and sloppy, then we run into an unsafe condition. Well, we have two different large size gauges to go to. We have the no-go gauge, and then we also have a field gauge. Now, I don't have a field gauge here with me because field gauges are more designed for armor type inspections. They're designed to determine when a rifle has become unsafe, either because of wear or because of damage to the rifle itself. If the rifle chambers a field gauge and the bolt will close on a field gauge, just like you saw us do on the go gauge, that means that a potentially unsafe condition exists and you may have cases rupture if you fire them in that rifle. Well, we're not just worried, since we're building rifles, we're not just worried about checking to see if a rifle has exceeded its service life. We want to make sure that it's going to be snug, it's going to be accurate, and that the barrel has service life left. That's the purpose of the no-go gauge. The no-go tells us that this is the upper end of what the chamber should be at when it's new. So, same thing for the no-go gauge. We drop the no-go gauge in, slide our bolt in, and in this case the bolt should not turn. The lug should not be able to go deep enough into the receiver extension to fully clear the lugs in the receiver extension and allow it to turn. Now, in this barrel, even though it's marked .308, it will turn. So it fails the no-go test on a commercial .308 Winchester gauge. Now I'm sure you're thinking at this point, wait a minute, it's a brand new barrel. It failed a Headspace test. Well, now we need to take the test a little bit further, and we need to determine if this barrel is safe or not. We also need to determine what the headspace is in it, what the upper edge of it is, how far we can go until the bolt no longer closes. If I was doing this for a living and I built tons and tons of rifles, I would have a full set of headspace gauges in varying increments well beyond what the field gauge would be. That way I can drop that gauge in and I can get an exact dimension on that chamber and tell me exactly where I'm at. Now I don't have a whole range of headspace gauges to be able to accurately measure this chamber. What I do have is this neat little tool right here. That's right, a roll of cellophane tape. I know what you're thinking, that cellophane tape is probably not a tool that really would have a whole lot of use in precision rifle building. However, it does. One thickness of cellophane tape actually measures approximately 2/1000ths. So the way we can figure this out, or the way we can verify this, because there may be manufacturing tolerances at the tape factory on that day, is we take our calipers here and we measure, or not measure, but we close our calipers on our no-go gauge and we zero our calipers out. We stick our little piece of cellophane tape on the back of here and we measure again, and we come up to 2/1000ths. Well, that tells me that once I've trimmed this piece of tape off the back of here, my no-go gauge that is normally 1.634 is now a 1.636 gauge. I did this earlier, took this gauge with the cellophane tape on the back of it and trimmed, and went ahead and dropped it into our chamber, and the bolt would not close on the 1.636 gauge. So that tells me that 1.636 is the upper limit. It will not close on that. Now I can look and see where we're at in our headspace figures. Now real quick, on the 308 commercial Winchester figures, the go is 1.630, the no-go is 1.634, and the field, which is the unsafe condition, is 1.638. Well, it will not close on a 1.636. So that tells me I'm below the field gauge. It won't close on that, so we're still within safe ranges for our Winchester commercial ammunition. So this barrel combination and this bolt is safe to fire .308 Winchester commercial ammunition. Well, we're not just looking for safe to fire, we're looking for accurate though. Well, here's the thing. Most of you guys that are building semi-automatic .308s are probably going to want the capability to fire surplus ammunition. At the least, you're going to want the capability to fire M118 LR, which is the current issue for military snipers. M118 LR is 7.62 NATO specification, so we want to be able to chamber that if the factory that's producing it is on the large end at that one day. Well, if we flip over and we take a look at the headspace dimensions for 7.62 NATO, the go gauge for 7.62 NATO is 1.6355. Well, we know we could close on 1.634 and not close on 1.636. So that tells me we're probably right about 1.6355. So we're about at the minimum specification for 7.62 NATO. We know it would not close on 1.636, and the no-go for 7.62 NATO is 1.6405. So we are well below the no-go for 7.62 NATO, and we're not even close to the field for 7.62 NATO, which is 1.6455. So that tells me that this is really a 7.62 chamber in this barrel. It's a minimum 7.62 chamber, but it's a 7.62 chamber. So this barrel with this bolt combination will safely fire .308 Winchester commercial ammunition and safely fire 7.62 NATO ammunition, which that is really the condition that we want to be in for this type of rifle. Now, this little segment, I'm sure, has probably got your brain burning up right now, so we're not going to install the barrel in this segment. We're going to do that in the next segment, and I promise you it will not be weeks like it was for the last segment. The holdup the last time was we were waiting on this bolt carrier group, and we really couldn't go ahead until we got the bolt carrier group in and could do the headspace check on the barrel. So going forward, we'll be moving these up, picking the pace up just a little bit. In fact, we only have one component left that hasn't showed up to totally complete the rifle. So we'll be moving along as quickly as we possibly can now. If you've liked this video, please give us a thumbs up. If you've got questions or comments, leave them in the comments section below or send them to us on Facebook or Twitter. If you're a subscriber, thank you very much. If you are not a subscriber, please subscribe. Also, want to make sure that if you have not already, please check out the other videos in our Mega Arms MATEN build. That way you're brought up to speed on what components we use to assemble the lower receiver and why we chose the stock that we chose. We will be moving forward, as I said, with the next installment on how to install the barrel in our Mega Arms monolithic upper receiver. Even if you don't have a monolithic upper receiver, you'll want to watch that episode because what we're going to do applies to a lot of other barrel installations as well. Until next time, get out and shoot!